See some familiar faces here. Also nice to see Zvonimir from the Algebra University. I think we have a couple of student groups. Also see Armando, seasoned Cosmos developer. So I think we have a very wide array of engineers here, students, and those that are interested in our hackathon and in Cosmos. And to give some context, this is the second session and the final session before we formally begin with the hackathon tomorrow remotely. The remote phase will be mostly for also getting fully acquainted with all the tracks, with all the documentations, materials, all the context that you need to be best prepared for the in-person segment then, which is kind of where usually most of the hacking then takes place. So even if you're not that familiar with one of the tracks, or you still kind of need some time to properly get familiar with everything, but you're planning to be at Cosmos or Hackmos on ground next week here in Split, Croatia, then don't worry about that. You still have time. Also, the Optimum team, which I welcome also to today's session, they will be giving you a introduction now. I asked them to also keep it beginner friendly because it's very deep technical stuff that they're building. I will give it over to Kishore in a second. But before that, I'll also introduce Zafarjan from our team. He's our ventures lead, and he will also share a couple of links here in the chat. So please keep an eye on that as well, because you will basically need to register for two things. If you want to participate in person at the hackathon next week here in Split, then you can apply for a complimentary pass, which gives you also full access to the conference, fully catered. You'll have a nice lunch buffet, you have coffee breaks, all these kind of things involved. So you just need to show up and you can enjoy the conference. And then the second thing is that you will need to have a profile on DoraHacks, which is where you also submit your biddle, which is basically your project on one of the tracks, right? Last week we had the introduction to the Cosmos track. Today we have the introduction to the Optimum bounty, which is also very unique in how it's kind of designed. I think that's most of the organizational stuff. Did I forget anything, Zach? Okay. Yeah, I think that's good. Kishore, I guess I give it over to you, and yeah, then the stage is yours.
Absolutely, thank you. So, hello everyone. It's great to meet you all. It's a privilege to be speaking with you. Professor Muriel Medard was supposed to actually be here, but she has conflicting appointments. Instead, I'll give you an introduction about the team and the work, and try to be beginner friendly. It's a complex product, as you mentioned. And without further ado, I will share my screen. And I'm going to put it on slideshow. Great. And of course, when I am presenting, I cannot see chat messages, or I won't be able to see. So feel free to if you have any questions, channel it to me. I see some people are admitting them. I'm happy to take questions as we go along. So I'll explain for about 30 minutes, the high level, the introduction, 30 to 35 minutes. Then I'll pass it over to Jeffrey. So with that, so Optimum, it was started last year, but it had its roots long back, 20 years ago. So the goal is to build the fastest decentralized internet protocol for the Web3 space. So it's a general solution that is suitable for different blockchain related work. So it was started. The original founders are Professor Muriel Medard, myself, and Ken T. I have worked with Professor Medard, Muriel, I'll call it, for quite some time, for over a decade. and Professor Nancy Lynch at MIT. Professor Muriel is a world-renowned expert in network coding and information theory. And Professor Nancy Lynch is very well known for distributed computing. So we raised some seed money, $11 million last year, backed by some very well-known PCs. That's where we are at today, and able to, carry forward the project. So today's blockchains. So Professor Muriel's, specialization is information theory and like a low latency networks, reliable communication in various domains, and coding theory. These blockchains are, they're bounded by, in terms of capacity, that they have latency. It's a, high latency in communications. Also, as a result, it translates to lower throughput, low bandwidth. And they also bloat the state. You have to store the state of the system. There are a lot of scaling challenges. And also a lot of them are often comes from another challenge is decentralization. I'll talk about it, what it means. There are a lot of, students also. So, and the first idea we had is that there are several kind of products. The one that's very directly applicable is valuators. That's how we are starting our journey with. And it's a network. So the idea is that if you can somehow figure out that, so now you publish a message to a node of participants in a decentralized environment, it would be great if that message shows up in all other nodes that are participating as quickly as possible. So essentially, you can think about, so now decentralization and distributed, there is a slight difference. Traditionally, when we did distributed system, we always have some controller that makes the decision, controls the other nodes that are participating. Decentralized, this role of that centralized control is extremely minimized, mostly in orchestration and setting up, because in decentralized systems, people take Byzantine behavior very seriously. And the Byzantine behavior, again, I'm filling in this detail for students, is that they model as a distributed computing problem back in 1981. At that time, blockchain was probably non-existent, and this problem was formulated by Leslie Lamport. So Byzantine general problem is that it was said in an anecdote that a group of generals need to decide whether they are going to attack an enemy together or retreat. And they communicate via messengers. And messengers might be lost, killed, or anything can happen. But they need to agree. So the idea is that there are generals who could be traitors, who might send one signal to one general that I'm going to attack and tell another guy that I'm going to retreat. This creates confusion. But the goal, what we want is that as long as the general is honest, can the set of generals come to a correct agreement together, not conflicting agreement? And can they actually come to an agreement? In asynchronous system, it was shown by Nancy Lynch, Professor Nancy Lynch at MIT, one of Muriel's collaborator and our advisor, who did a lot of the work with us, is that she showed that it is not possible, even with 3 such nodes, when you translate it into the world of computers. Asynchronous in network, nodes can be malicious, Byzantine. In fact, it's not possible to solve it with termination guarantee. You may keep trying it. Then came Paxos algorithm. Then came, Paralyskov's algorithm. But Paxos is not for actually Byzantine. It has asynchrony, failure, crash failure, etc. So this eventually culminated in, today's blockchain. A lot of these algorithms are based off some of the research and modifications. So that means inherently this problem of agreeing on something, collectively autonomous systems behaving like a logically centralized system, is actually what blockchain implements often. Core algorithms, the state chains it implements. And that's a very hard problem to do. In the proof of stake, which is the most dominant or popular form today, not proof of work is Bitcoin. Proof of stake, they believe in that every node has some voting power, and they make decisions by casting vote. So most of the algorithm says the following: as long as less than 1/3 of the nodes are not, like a dishonest, that means you cannot have more than 33% dishonest, these algorithms will give you safety. It will be correct. That means it will behave like a correct centralized system, and it will solve the repeated consensus problems. Behave like a centralized entity. A lot of people call it decentralized oracle. Now, asynchrony is another angle. It's the asynchrony means when you send a message from one node to another in the network sense, the meaning that the message will arrive, but we have no guarantee. You fix it will be 100 milliseconds. Don't be surprised if someday it's more than 100 milliseconds. Then you like 200 milliseconds. Someday it may exceed that. So that is called asynchrony. And that's very hard to design an algorithm that will show progress under asynchrony. In fact, consensus is shown to be the result I mentioned, FLP, Fisher-Lynch Patterson, that it's not possible to terminate or guarantee termination. So now, then came up with the idea that is commonly used called partial synchrony. There is a definition. The approximate definition is that after a certain period of time, which is the most common definition for partial synchrony, there are two popular definitions. Global stabilization time, which you don't know when it will happen. You have no access to. All the messages will arrive within some interval. These are slots. These slots, this is the slot you use to make a decision collectively. So because it is proof of stake, one thing they need repeatedly is take votes. When you want to have votes, you have to say what people should vote on. And that is where you need fast propagation. That, guys, one node sends whoever is proposing that, can you vote on this, please? And that takes a lot of time. If you can shorten that, then you can make the slots faster. Under this partial synchrony, delta, what they call it. And that RLNC, a kind of code, a new form of code invented by Professor Medard and her team at MIT, shows that actually, when you want to send a message encoded with this coding scheme, all these equations, it forms equations, lots of linear algebraic equation in a finite field. They travel around different parts of the network, and wherever enough of them collects together for a message, they can decode the original message back. It reminds me of those Terminator movies where he's melted and then all these different melted droplets collect together and he emerges from it. It has this magical feature. So now this allows you to travel like many paths same time, but one message fragmented itself. And some can be lost, some can be stopped. Still, as long as enough equations propagate through the network, messages will be recreated. And that's a beautiful property. So we implemented a system where one node publishes, and we want to see how long does it take to get to other nodes. Of course, this quorum or voting is used in most proof of stake systems, as long as they're decentralized, they have a large number. Let's take Hoodie, for example. It may take 1,000 milliseconds, and then we implemented RLNC-based algorithm called MUMP2P. We found it keeps on fluctuating, of course, 6 to 7 times faster than the traditional gossip sub, libp2p based, which is what UDI testnet's consensus layer uses. Now, of course, we brought it to the commercial world, or the world of blockchain rather, and started partnering who might want to use this. And then we have worked with validators. So validators gain by actually that they can propagate their proposed blocks faster. And it makes several types of gains. Better MEV, or avoids, kind of faulty, kind of missing any deadline, and spend more time computing, looking for a better blocks, even in the PBS model, proposer builder separated model. And so this is the progression. And now we have a private testnet, which is separate, and we do it by invitation, and they are testing it. So so there's more than just network. You have also storage. These are different features we are rolling out one by one. So as a whole, we call these nodes, which are lightweight. Lightweight means like a usual commodity hardware would do. A desktop doesn't have to be very high machine. They are flexible. You can run on any network, doesn't have to be high speed. You can join in a permissionless way, and then they scale. So what does MUMP2P provide? Any question I'm happy to answer at this point. Before I go, I'm going to explain actually the internals a little bit. So what the high level it does is that think about a network of nodes. They belong to the MUMP2P network. This is the core idea. They may be located in different parts of the world. Some are in Boston, US, Europe, Western Europe, Tokyo, Sydney, anywhere. Now, any validator or any user wants to publish a message. And those are in blue diamond shaped icons. Someone is publishing, and others subscribe, whoever is interested. And it goes by topic. You can have many topics. So once it's published, it spreads through this RLNC process in all other nodes. So do not be misled by the images that glyphs that the message goes as a whole. The message goes in all channels. A little bit of equation. It just pops up on each node. That's why I did not show the message flowing in any of those links, because no single link transmits the whole message. It's not even sharding. Sharding, if you are doing sharding, you cut the message into separate pieces, say 10 pieces. All 10 pieces have to go to, independently and assemble. RLNC is that you create a message and cut it up into, say, 12 pieces. As long as any 10, there is a threshold, of course, shows up, you can reconstruct the message. Some can be lost. This has many advantages. Is that imagine you have a message to transmit, large message, and you encode in a way that it creates some message, 20 messages. And if 16 arrives, you can decode the message. There is a redundancy, of course, that four additional packets. Because of that overhead, you can flexibly adjust that. As long as you recover 16, you are good to go. Why would the remaining four pieces might be lost? Many reasons. It's a decentralized system. Network might be down or very slow. Also, by order statistics, you are avoiding the slow guys, which are called stragglers. So increasing speed, fault tolerance, so that means reliability of this. And you don't have to decide that number upfront in RLNC. Unlike some codes, this is a rateless code. That means keep sending. And they are all different packets. As long as you get 16 of them, you can decode. So they are not even the same message. You just encode it. Keep combining these equations to create more equations. So anyone who is subscribing, they will get. Now, any of these nodes can do this publish, subscribe. In the hackathon, you will have two aspects. One, you will actually have a network by yourself. Then from your machine, you can publish, subscribe, see the messages, and you can play around, see how messages flow. In the meantime, we'll provide a local Docker compose that you can create your own network, as many machines as you like. And also we'll later on the final day, we will provide you an actual network, your own cluster, and you can play around with these machines geographically spread around. We'll give you the IP address, access to them, and where they are located. And you can do interesting experiments. Lots of different things you can play around with. So let me tell you a few idea about this pub/sub mechanism that traditional gossip uses. Traditional gossip uses libp2p, which is the Ethereum consensus layer. It has the idea that it creates certain nodes pairings, which is called full message pairing. Usually, messages go through this full message pairing. There are a few exceptions. We built our technology in a very similar fashion, but except we send equations and no full length sends the whole entire message. And it also has all the security features of the libp2p, which has been battle tested and stable. So it just, but essentially it has a lot of these features. So now I'm going to show you a comparison between an identical network. I'll show you a video, two identical networks, and I'm going to publish messages at the same time and see what kind of messages you can publish, how fast, etc. So now I'm going to play this video for you. It is long, but I won't take all 5 minutes. But can you make sure that you see my video because it's embedded? And somebody?
Yep, we see it.
Okay, great. So you're going to take 36 nodes of gossip sub. This is the original, very well-known libp2p implemented. It's used by libp2p. It supports. This is the most common gossip protocol actually. And then we have 36 nodes. So what we do is we will go to the setup. So now we have, nodes spread around the world. The size of these round blobs gives you that more nodes are. So we have in Asia, Australia, East Europe, etc. Another one, colored differently, and will run together. Okay. So here is the goal. Now let's see. This is going to show you latency. And I'm going to publish in a topic. It's a random topic, 5 MB messages, 1 per second, randomly ingest, and see, keep comparing how it behaves. So here we go. I'll run the, I'll speed up it at the interest of time. I want to show you, yeah. So what you are seeing is that it's publishing messages and you are seeing latency. On the left-hand side is the RLNC-based gossip, Optimum P2P. And on the right-hand side is the gossip sub. So the latency of gossip sub is higher. Of course, you may think that what's the relative kind of latency difference? That depends on how fast you are publishing, and the size of the messages you are publishing. So, and this is an identically distributed similar machines at a much larger scale. So then you can increase the size of the message, and we compare. At some point, you'll see that if you publish large messages and at a higher throughput, the latency of Optimum P2P is stable, but gossip sub keeps on increasing. That is because perhaps the queue is building up. It's not able to keep up with it. Of course, eventually, as you keep increasing the message and the rate, the Optimum P2P will also build up queues, but you have to push it a lot harder. The breaking point is much higher. That is because it has the ability to parallelize the information, can sustain losses easily, and also avoid stragglers. So there are several things, qualities that are coming together to make this happen. And these are the properties of the RLMC. So I want to show you another quick, okay. So essentially, in real life, like if you are using it to connecting to Hoodie, you can do tests, but I won't talk too much about it. This is how publish and subscribe works. This is just a diagram. This is again schematic diagram that in your hackathon you will have your tools or gRPC, or if you want a tool, you can publish to any node, any of these nodes, and then subscribe. And and do interesting experiments. And you can connect with any favorite programming language you like. We'll make the protobuf proto file available, and you will have README, and then you can play around with that. We can talk more about it, and maybe I can, Santiago, if you are okay, if you want to talk about, this is the second hackathon. We had one at MIT about a month and a half ago. Santiago, do you want to say a few words about it?
Yes, so this is, we had our first hackathon at MIT about a month ago, and we had about 17 people participating with, some of them were like college students, some of them were professionals, and they were tasked to play with our infrastructure. Same principle as what Kishore demonstrated, publish and subscribe messages through the network using the MAN-P2P CLI, and then run some experiments, see what kind of interesting information they can make out of it. What is the latency? What happens if you publish and subscribe from different regions? What happens if you increase the message size? What happens if you just publish, a lot, or like slower publishing or faster publishing? And then, different teams were able to, run some different analysis and then present what they found. So I think this new hackathon, people will be able to use your PC client and run some experiments. And we have different kind of tracks for data analysis that the marketing team is going to present later. But it was very fun. People had good time. They were able to learn quite a lot about infrastructure and about Optimum products. And hopefully you will also have a good time.
Yeah, thank you.
Kishore.
Yeah, so then we will be providing some materials about how we organize, how we'll reading materials, very basic, or how to connect all these and on a channel, and then we'll go from there. And then I think at this point, I'm happy to answer any questions. Otherwise, I'll pass it over to Jeffrey. Okay. So advance the question. Okay. I have a question. I see a question. I think it says that RLNC speeds up gossips out by full block retransmission with lightweight coded shards. So every packet receives contribute new information that casts redundant bandwidth from this. I see. Okay, so that's a comment. Yeah, thank you.
I think so far we don't have actual questions. I see here also some people commenting and providing additional information to what you just said, which is quite informative. But yeah, so far there is not really a lot of questions in the chat. I would just recommend also to join the Telegram group, and in case you have also specific questions, ask them there, and I will also pin the documentation in the Telegram group as well. But yeah, in case you have also right now any kind of question, feel free to unmute you and ask directly. Otherwise, I will give the word back to you as well, and then I think Jeffrey can take it from here.
Yeah, I think there is someone. Yeah.
Maybe one quick note here as well for those that are maybe not deep in the Web3 trenches and maybe don't have deep kind of experience in blockchains in general. There will be people on ground that will also be looking for team members. And I think our job as the organizers is also to ensure that you will find a team that maybe fills a field of expertise that you don't feel 100% comfortable in. So if you want to join our team, or if you want to form a team and you have already 1 or 2 members in your team, but you're looking for a third, fourth member, then just connect with us, send us an email, send us a message. We already got a couple of emails, but keep sending them, and we will help match you with teams so that you feel very comfortable, that you feel also that you have realistic chances of winning some prize money, because of course that's also part of the game, right? So yeah, with that, I think I'll give it over to Jeffrey, unless Shuri, if you have anything else. But yeah,
I have. Yeah. Unless somebody has questions, I'm happy to. Yeah. I'll let Jeffrey take over.
yeah, Jeffrey, take it away.
Yeah. So maybe there is a coding decoding question I see repeatedly. So when you send the data, so there is something called as you encode, the first few can be something called in systematic form. The packets are out clear. You don't even have to decode. Suppose there is a loss, then you will get an equation. Then you actually have to decode it. That equation can be easily solved because you have the other equations already solved. Another way is that the message, you solve it by multiplying by these coefficients. For each message, he has his own, however large the message is, that coefficient matrix is the same. So that means when you decode it, you need to compute the inverse only once. Let's say it's 20 by 20. You can compute those, say your matrix is 3, 5, 2, and 2, 3, 1, 1, 5, 7. Those are your coefficients. They form a matrix. And you just compute the inverse once. Now you may say, what if it's not inverted? There is a result that is extremely likely to be invertible. Maybe once in billion, you may not be able to invert, but then you regenerate. So this same matrix, once you invert, even if it's 20 by 20 dimension, just invert once. And it's a simple, even in the worst case, NQ algorithm. And then you just multiply the coded data with this. So you'll decode it. So that's why at one shot you decode. Yeah, exactly. It can use Gauss-Jordan elimination on finite fields, except not real numbers. These are finite fields. They follow the same rules of fields. Hopefully that answer. Yeah. So over to you, Jeffrey. Sorry. Yeah.
No worries at all. Hi everyone, I'm Jeffrey, community lead here at Optimum. I'm going to run you through the tracks that you can expect to be taking part in and the prizes and things like that. So I'm going to share my screen so you guys can have a look at them directly, but you can also head over to the Dora Hacks page and see it there too. Cool. Can everyone see my screen at the moment?
Yes, it is visible.
Cool, nice. So the first tracks, we're gonna have 3 main tracks. The first one will be the experiment track. So the goal here is to essentially compare, gossip, and Gossip Sub and Mum P2P, and empirically prove where Mum P2P is superior. There are also 2 subcategories. So the first 2 tracks will have 2 subcategories. So I guess the prize for the overall track is $1,000 plus a paid coaching opportunity, and then you get an extra $1,000 for the subcategories here. And along with all the tracks, you can get links to the developer docs. I saw there was a question about that in the chat, and then also Telegram support and that sort of thing. So, yeah. The next track is the scaling and stress test track. Again, there are 2 subcategories here. Here, the goal is to just push the network to its limits, using varying sizes of the messages, and try and see where you can find break points and issues and things like that. Again, the prizes for subcategories and the overall goal here as well. And again, links to everything you need. Yeah. And then for the third one, we had the visualization and insight track. So this one doesn't have subcategories. It's just the $1,000 and paid coaching opportunity. So this is for like building dashboards, charts, explainers, that sort of thing, making the results easy for people to understand. So validators, researchers, and developers. I also want to mention that outside of the prizes here, like if you're participating in any of our tracks, we also have opportunities for people to become technical ambassadors in our community. We also have opportunities to potentially give you guys early access to some of the products we're working on down the line. So I myself, I'll be on the ground during the hackathon in Split. So winners, people who take part, I'll be taking down you guys' details, speaking to all of you guys. So if you're interested in the technical ambassador roles or anything outside of that, or getting that exclusive early access to some of the things we're working on, we can definitely get that sorted and organized for you guys. But like I said, this stuff is on the Dora at Hacks page, so you guys can check it out. Be available on Telegram as well. So please ping me if there are any issues. I'll be your touch point to the rest of the team. So you'll see me pop up in the Telegram soon.
Thank you, Elliot.
Any questions? I can't see the chat at the moment, so if there are any questions,
Yes, there was one member here. He asked if he can have a question. Feel free to just unmute yourself and ask a question. I'm sure Jeffrey is keen to answer it.
no question.
In the meantime, for everyone here in the call, feel free to join the Telegram group that I also just linked here in the comments, and go to the Optimum channel, just like write Gmom in it, or like the GM version of Optimum. But yeah, I think in the meantime, there is no other.
Excuse me, Jeffrey.
Sure.
If I may ask, is it possible in the first track to maybe win the subcategory and not win the overall category? If you get what I'm asking, is it maybe possible to have the best solution for subcategory 2, but not have it for the overall statement or subcategory 1?
So I guess this would probably be a question for the technical team.
Actually, yeah, I can hop in here. So there are 2 ways to win each category. So there will be one winner for each subcategory within the tracks. So there's no, if you win one of the subcategories, you've won. You could attempt both subcategories and win both. But there will be one winner for each of the subcategories. There is no track level winner on top of that. If that makes sense.
I see. Thank you very much.
I have a question. For deliverables, are you guys looking for like a document or a presentation or both?
I put that to the team, but I think a presentation would probably be the best way to move forward. But yeah, in my
I
opinion,
can answer that. So at MIT, we ask participants to just prepare some slides, show what they've done. You can give a quick presentation and then use some slides to support your presentation. But there were some teams that, for example, did not have slides. They just presented in front of the audience what they discovered.
And how much time do you have to present?
I think there is no time limit. I think some of the teams, they took a couple of minutes, between 2 to 5 minutes, just to show your approach, what you try, what worked or did not work, and your conclusion. Nothing too complicated. It doesn't have to be too long.
If there are no further questions, then I guess we can wrap it up here. Or is there anything?
We have one additional question in the chat. There is someone who can't attend but wants to participate. I think the best is just like join the Telegram group, and we also have a subcategory, a subchannel there. Make a team. As a reminder, this hackathon will be hybrid, meaning it starts tomorrow and will be online until the conference starts on October 30. And then there will be in on ground in real life a hackathon, and the presentation will be on November 1st in real life, and just one member of your team has to be on ground to present it. So in case you can come yourself, just find a team in the Telegram channel, and if one member of your team is there and can present, that will be no issue at all.
But also for FAM specifically, like I saw your email and I replied to it also, like we've been in touch before. So yeah, once we engage, once we take note, like we will get back with contacts from registered teams, which will start tomorrow. So I think from tomorrow we'll have teams formed, and then we will we'll match them with requests from remote members that want to join teams that are going to be in split. But yeah, because yeah, tomorrow is day one. We will have the conference opening on the 30th of October, which is already in 8 days. And then in the morning, we'll also share the exact agenda when we will have the in-person opening in the Hackmos Lounge, which is basically the developer stage and co-working zones. We'll have beanbags in there. We even have like Nintendo Switch. We have some like stuff that you also can take some time to chill, and food will be there. Everything is going to be taken care of. So yeah, as Savitjan said, register for the Hackmos forum. That's the most important one if you want to be on ground to receive your complimentary ticket. And everything else will stay in touch. We also have Twitter, of course, same for the Optimum team. Follow us there as well. We'll share some updates. But yeah, I think that's all, unless anyone else has something else to share. Otherwise, I would say thanks Kishori, Jeffrey, Santiago, Eli, of course, and Muriel will then also be on ground and split, I believe. So yeah, you can also meet her there on ground. All right, thank you so much, and see you guys next week.
Thank you, everyone.
Thank you, everyone, for your time. Have a good rest of your day.
Thank you.
Thank you. Take care.